how much pallor area is present on your RBC again? Gaano kalaki ang pallor area na yan? Normally.
1/3 po. 1/3.
Third. Tama? So if this is my red cell, you have there around 1/3 pallor area. And if you recall it, that 1/3 pallor area will provide your red cell its deformability, will allow your red cells to deform, will allow your red cells to expand whenever they are exposed to hypotonic solution. Right? Then, aside from that, aside from this pallor area, everything will then be red. Right? Referring now to your hemoglobin. The hemoglobin that you have synthesized during erythropoiesis. And to make sure that your red cells will appear like this, definitely, you need to provide them essential nutrients or essential minerals. Say, for example, on your red cells membrane, what are the 3 components of that red cell membrane again? Naririnig ba? What are the components? You have
Lipids, carbohydrates.
you have carbohydrates, you have proteins, and you have lipids, right? So to make sure that red cell's membrane would be intact, to make sure that red cell becomes deformable, then we need to ensure that those components are present, right? To make sure that you have enough hemoglobin inside, you give them B12 and folic acid for DNA metabolism, tama? B6, iron for heme synthesis, and so on and so forth. So generally, you need these essential vitamins, you need these essential components to make sure that your red cells will be not just normal in function, but to make sure that normal red cells are normal in morphology. Kasi just imagine, if red cells are smaller, if red cells are larger, if red cells are pale instead of being red, di ba? If they are pale, automatic, their function would be affected and they become susceptible to lysis. And we do not want that to happen, right? We want our red cells to be physically strong to make sure that they can then survive within the circulation. And internally, we want our red cells to have enough hemoglobin so you can fully perform your duty in transporting oxygen. So point is, when it comes to morphologic abnormalities of RBCs, any problems or any deficiencies or anything in excess with all those nutrients, with all those minerals that we have mentioned, expect that there will be changes on the structure of your RBC. Kunyari, let's say you have less hemoglobin. What do you think will happen to the size of your red cell? Will they be larger or will they be smaller?
Smaller.
Ba? Kasi konti yung hemoglobin. So kung maliit yung RBC natin, knowing that there's less hemoglobin, its ability to bind and carry oxygen will then be affected. Right? Imagine, you don't have enough proteins on your cell membrane. For example, you don't have enough spectrin, if you recall it. Expect that the shape of your RBC will then be changed. And changing the shape of the red cells, aside from the normal scenario of being deformable, will then result to increased susceptibility of RBCs to lysis. So that's why, if you want to have that normal process, normal structure, and normal function of RBCs, those minerals, those vitamins, those nutrients that you have learned should always be in place to make sure that red cells will be ready to bind and to transport oxygen. So today, we will then be dealing with 3 variations on your red cells morphology. So we will deal with variation in the size, in the color, and in the shape of your RBC. So to begin with, when it comes to the size, ano uli ang normal size ng RBC natin?
7 to 8 micrometer.
7 or up to 8 micrometer in diameter. Tama? So here's the thing. In the laboratory, we do not measure that diameter of your RBC. Instead, what we measure in the laboratory is the so-called MCV. What does it stand for again?
Cell
In cell volume.
cellular volume.
Volume. Right? You are measuring the volume of the cell. And remember, the volume of the cell is directly proportional to the size of your cell. So what we measure in the lab, even using automated machines, or you can compute it manually, what we measure to know the size of the red cells would be your MCV. And normally, ano uli yung normal MCV natin? Kung matatandaan nyo pa. Normal MCV will range from, still remember?
80 to 100
to 100 femtoliters, right? So if after computing for your MCV or after measuring MCV using an automated machine and the value falls in between 80 to 100, you call your RBC then as normocyte. Obviously, okay, it's normal in size. If it's less than 80 femtoliters, how would you call it then?
Microcyte.
Microcyte. Obviously, higher than 100 femtoliters, you call your red cell as, or you classify it as macrocyte. Tama? So any variation in red cell size, particularly being microcytic or macrocytic, remember, the term we use to denote variation in red cell size is what we call as anisocyte. Okay? So if you have a lot of microcytic or macrocytic RBCs in the blood, meron kang anisocytosis. Okay? But if you're just referring to a red cell varying in size, you just simply call them as anisocytes. Okay? And here's the thing. You a whiteboard ko ha, you follow me, okay? Here's the thing. As we discuss later on, anemia, yan yung mga red cell disorders natin, to make it a lot more simple and a lot easier to understand, we will classify them based on the morphology of RBCs. Okay? So for example, red cells are said to be normocytic. Ano uling ibig sabihin kapag normocyte?
Normal size.
Normal size.
Normal in size. Okay? Here's the thing. Remember this. Looks could be deceiving. Okay? When it comes to RBCs, sometimes your red cells may look totally normal, especially in size. They look totally normal in size. But then, deep inside your patient's body, there is an underlying disease. Because there are red cell disorders resulting to anemia wherein your red cells appearance still looks normal. So hindi porket normal yung size ng RBC natin, you are not going to suffer from any red cell disorder. You are not going to suffer from anemia. Okay? There are diseases, there are types of anemia wherein red cells still look normal in size. And what are these, sir? So example, we have here aplastic anemia. You have here hemolytic anemia. And you have here bleeding, or particularly acute bleeding. When you say aplastic, your bone marrow is aplastic. What do we mean by that?
No production.
There's possibly absence or very low production of cells, right? Or you think of it like this: quality over quantity. In aplastic anemia, you have a problem in the production of cells. Your bone marrow fails to produce enough number of cells, but the ones they produce still totally looks normal. Normal in size, they have normal hemoglobin, but your problem here resulting to anemia is that the number of circulating RBC is low. Kaya parang quality over quantity. Your red cells look normal, they have enough hemoglobin inside, but the number of circulating red cell is low. So that's why you still end up with anemia. Do you get that?
Yes po.
Yes,
Yes
po.
po, sir.
Okay. By the way, don't worry kasi sa finals, we will further elaborate that, ha? What are the causes of aplastic anemia? What are the laboratory features of aplastic anemia? And so on and so forth. Okay? Basta, as of the moment, isipin nyo, if there's aplastic anemia, red cells will still look normal in size. Okay? Then, what do we mean when we say hemolytic or hemolysis?
Naglalays po yung
Red cells are destroyed. Right? For whatever reason. Tsaka na natin pag-usapan yon. What causes lysis of red cells? But right now, just think of red cells are being lysed. Imagine, you have 100 red cells right now on your monitor. Imagine, you have 100 red cells right now in your monitor, on your screen. 75 of them were lysed. Nawala yung 75%. The remaining 25 still are not yet affected. So if you will extract blood and that 25 will be on your smear, what do you think what do you think would be the appearance of those remaining 25 RBCs?
Normal.
Normal.
They still look normal. Tama? But out of 100, imagine, sir, 25 na lang po yung natira. Will you end up with anemia?
Yes.
Yes.
Will you end up
Yes
with anemia? Yes. Why? Because, again, the number of circulating RBC is low. Again, quality over quantity. Do you get that?
Yes.
Yes po.
Okay.
Yes po.
I hope you're getting the point. Okay? Then, bleeding. Well, let's say acute bleeding to be specific. Let's say your patient was stabbed 20 times. 20 stab wounds. Your patient lost blood. So as your patient lost blood due to that excessive bleeding, he lost red cells. Tama? But if you will extract blood for examination, still expect that your red cells will still look normal in appearance. The problem is, your patient may die because the number of circulating red cells still is low. So if you will look at the bigger picture here, sa kanilang tatlo, what's common? Red cells look normal but you end up with anemia. What's common between these three?
Low number.
Low number of circulating.
You end up with anemia because the number of circulating RBC is low. Are we clear with that?
Yes.
Yes po.
Okay? So, for normocytic cells again, baka yun lang matandaan nyo ha. Looks would be deceiving. Red cells totally look normal, but inside, your patient may have some troubles. Your patient may have some problems. Your patient may have some forms of anemia, wherein red cells may still look normal, but the number of circulating red cell is low, thus resulting to anemia. Okay? Then, next up here is microcytic red cell. What do we mean again when we say microcytes?
Small.
Small.
Red cells are smaller in size, right? And usually, we associate microcytic RBCs in cases of thalassemia. Naalala pa ba? Ano yung thalassemia uli?
Problems sa production.
Problems in gluten synthesis, right? So you have thalassemia, you have anemia of chronic disease, and you have here sideroblastic anemia. Basically, just you go with the general muna, okay? Basically, red cells here are small because you have a problem in hemoglobin synthesis. You have a problem with the amount of hemoglobin you form. In thalassemia, sabi nyo, globin. Diba? It's a domino effect. Less globin will mean less hemoglobin. Tama? Iron deficiency anemia. When do you need iron? When it comes to red cells?
Yeah.
In
For heme synthesis. Tama? So domino effect again. Less iron will mean less heme. Less heme will mean less hemoglobin. Right? And for anemia of chronic disease, still, it affects your iron distribution. So still, your problem is with hemoglobin synthesis. And with sideroblastic anemia, what do you mean again when you say sideroblasts? Ano uli ang sideroblasts?
Yung iron ko nag-accumulate sa
So
immature
these
cells.
are immature cells with iron deposits inside, right? Why do those iron are deposited inside again? Why do they accumulate? Bakit hindi nagagamit yung iron? Ano yung kapartner uli ng iron for heme synthesis?
Protoporphyrin.
Kasi possibly you don't have enough protoporphyrin 9. And again, it's a domino effect. No protoporphyrin 9 will mean less heme, and less heme will mean less hemoglobin. So in short, with all these diseases here, why are red cells smaller? Anong sagot? Why are red cells smaller?
Baba po yung hemoglobin.
Because they don't have enough hemoglobin. Hindi naman totaling walang hemoglobin, ha? They don't have enough hemoglobin. Do you follow?
Yes po.
yes po.
Okay, then lastly, when it comes to the size, what do you mean again when you say it's a macrocyte?
Larger
Our
RB.
red cells are larger. Okay, let's put it this way. You listen well, ha? When you say red cells are larger, it does not mean that you have a lot of hemoglobin. It does not mean that you have excessive amount of hemoglobin. I'll repeat that, ha? If red cells are macrocytic, it does not mean that you have excess or increased hemoglobin. It simply means to say that if red cells are macrocytic, there has been a problem with the maturation and development of your RBCs. In erythropoiesis, as the cell mature, the size becomes smaller. Tama? So meaning, those immature forms are larger, right? So, if I remember it right, last time, I give it as an example, di ba? Yung micronutrient deficiency. Tama ba? Nabigay ko sa inyo yun as example. Yes,
Yes
po.
po.
Di ba? So, meaning, if your red cells during erythropoiesis failed to receive enough nutrients, enough vitamins, enough minerals, expect that the size will not mature properly. Kaya, yung RBC natin is larger than the usual. So that's why you usually observe macrocytic RBCs in cases of liver diseases, kasi liver provides us those essential nutrients for red cells maturation, or you can go with this during megaloblastic states, which is true whenever you have deficiencies in B12 or even in folic acid, which are needed by your maturing RBCs. So pag sinabi nating macrocytic RBC, again, that is when your red cells failed to mature or to grow accordingly. Are we clear with that?
Yes.
Yes po.
So again, what is the term used to denote red cells variation in size?
Anisocytosis.
You have anisocyte or anisocytosis. Okay? So when it comes to hemoglobin content, you are actually referring to your red cells color. Okay? Kasi hemoglobin is the one that gives your red cells its color. Tama? So any variation in red cells color referring to hemoglobin content is actually termed as anisochromia. Chromia, it's color, right? So when I say red cells are normochromic, what do we mean by that?
Normal color.
Normal color.
Ready.
Normal in color, what do we mean by that?
Abnormal hemoglobin.
Normal yung hemoglobin niya. So sir, how do we know the normal or the hemoglobin content or normal color of hemoglobin? If in size, we have MCV, when it comes to hemoglobin, we have this thing called MCH and MCHC. Okay? MCH is mean cell hemoglobin. MCHC is mean cell hemoglobin concentration. Difference between these two is that MCH measures the weight of your hemoglobin. MCHC measures the actual concentration of your hemoglobin. So comparing these two, which do you think is better? Is it MCH or is it MCHC?
CHC.
Obviously, it's MCHC, right? Kasi you're after with the actual concentration, right? But if you will, if you're after with the values, if it's MCH, normally it's 27 to 32 picograms. O kasi it's it's a measurement of mass, right? So that's why your unit of measurement is with mass, picograms. Then with MCHC, it could be anything in between 32 to 36%. So when you say red cells are normochromic, it means to say that your MCH, your MCHC value technically are normal, right? And if you will observe your RBCs under the microscope using your blood smear, you will expect that your red cells have 1/3 pallor area. But then, just like in normocytic cells a while ago, looks could be deceiving. Red cells may look normal in color, but again, there may be underlying conditions with that. Question: if red cells are normal in hemoglobin content, will they have normal size? Uy! If red cells are normal in color, will they have normal size?
Yes.
Yes.
Opo.
Yes, po.
Meron. Follow-up question. If they are normal in size, should I expect the same set of diseases resulting to a normocytic RBC with normochromic RBCs?
Yes.
Yes.
Pareho lang kaya sila? What do you think? Pareho lang kaya sila?
Yes.
Opo.
So that's why in a lot of classification of anemia, remember that the color and the size of the red cells are most of the time paired with one another. So when you encounter normocytic, normochromic, you are referring to diseases with normal red cell size and normal red cell color. So you can associate this with, ano uling sakit na yon? You can associate this with aplastic anemia, right? Hemolytic anemia, and even platelet. Do you follow?
Yes, po.
Opo.
Okay. When we say red cells are hypochromic, how much pallor area do you think would be present? Less than one-third or more than one-third?
Less than one-third.
Less than.
Ulitin
More
natin.
than?
Red cells are hypochromic.
More
Ano
than
yung
one-third.
hypo sa kanya? Ano yung hypo?
Color.
The color, right? The hemoglobin content. So if red cells are hypochromic and you observe them under the microscope using a smear, what would you expect to your pallor area? Will it be
Larger.
less than one-third or more than one-third?
More than.
More than.
More
Should
than.
be more than. Tama? You have more than one-third pallor area, meaning your red cells are pale, leaving you less portions with hemoglobin. Tama ba? And if red cells are hypochromic, telling you that there's not enough hemoglobin inside, what would you expect to their size?
Small.
Micro.
They will then be microcytic, right? Follow-up question. Is it safe to say that microcytic hypochromic RBC will have the same set of diseases a while ago?
Yes
Yes po.
Yes po.
Yes. Tama? Expect it to be present in thalassemia, in iron deficiency anemia, right? In anemia of chronic disease, or even in sideroblastic anemia. They are small because they don't have enough hemoglobin. Do you follow?
Yes.
Okay. Then lastly, I would like to highlight this one, ha? I would like to make this thing clear. There are times when your red cells are said to be hyperchromic. Oh, you listen well. When you say red cells are hyperchromic, remember, it does not mean that you have excess hemoglobin. It does not mean that you have a lot of hemoglobin. Hyperchromic is just a description that your red cells do not have that pallor area. I'll repeat that. If red cells are said to be hyperchromic, it does not mean that your red cells have enough or have excess hemoglobin. It simply indicates that your red cells do not have enough pallor area. Again, what for is that pallor area on your red cells?
Deformability.
Formability, right? For their expandable characteristic. Imagine, if my red cells do not have this pallor area, what do you think will happen to these cells?
Prone to lysis po.
Lag.
They will then be susceptible to lysis. Tama? Imagine, meron lang pumasok na konting water or konting hypotonic solution. Red cells will be easily destroyed. Red cells will be easily lysed because they cannot deform, because they cannot expand, which makes them susceptible to lysis. And usually, we encounter hyperchromic RBCs in cases of hereditary spherocytosis. It's a condition where red cells do not have that pallor area, making them susceptible to lysis. Are we clear with that?
Yes po.
Yes po.
How about the others? Maliwanag ba?
Yes po.
Yes po. Yes po.
Okay. So again, what is the term used to denote red cells variation in hemoglobin content?
Anisochromia.
Anisochromia. Okay? Then, when it comes to the shape, we further call it as poikilocytes. So when you encounter the term poikilocyte, it indicates that your red cell vary in shape. Later, yun yung medyo marami-rami. Okay? We have different shapes that can be assumed by abnormal RBCs. Then, just an additional note lang, when it comes to red cells color, there are times that on your blood smear, on your right stained blood smear, red cells will appear appear polychromatic. If red cells appear polychromatic, what is the other term that we use to denote that specific cell?
Reticulocyte.
It's actually referring to reticulocytes. Tama? That if on your smear, red cells have this polychromatic appearance with blue, with grayish, with pinkish area, you are actually referring to reticulocytes. So on the right stain smear, retics appear as polychromatic. Supravital stain, yun. That's when you can then check the presence of RNA, right? But if on your smear, you've seen a lot of polychromatic RBCs, it can then simply indicate that there is excess production of cells from your bone marrow. Ang daming ginagawa ni bone marrow. Possibly because your bone marrow is reacting to certain stimulus. Example, there is hemolytic anemia. Your red cells are being destroyed. So because of that hemolysis, your bone marrow will react. Nasira yung red cell ko, kumonte yung red cell ko. So my bone marrow will then produce a lot more cells. And as my bone marrow produce a lot more cells, I will then encounter a lot of reticulocytes within my peripheral blood. Okay? Kaya if you encounter a lot of polychromatic RBCs, then possibly it then indicates that there is an excessive production of cells from your bone marrow. Okay? And aside from knowing that the different abnormalities, particularly with color, what's more important to that for us medtechs is that knowing these abnormalities here, it would be a lot better if we can report it accordingly. If we report it properly. Kasi you do not just say simply that there's polychromatic red cell. Kasi sa ayaw at sa gusto natin, polychromatic red cells or reticulocytes are just normal in your blood. So pag nakakita ka ba ng polychromatic red cell, will you report it right away as abnormal? No. Right? My point is, as medtechs, we should learn how to properly report those abnormalities that we see. So written on this table here, these two tables here, is that number one, this is how you should properly report hypochromasia. So instead of 1/3, if the pallor area of a lot of RBCs would be 1/2 of the cell's diameter, you can then report it as 1+. If totally the red portion is on the thin rim of your cells, you just report it as 4+, and so on and so forth. Okay? Then if you examine your blood smear, and then you think that 1% of the cells, the red cells in your peripheral smear are polychromatic, then you grade it as slight polychromasia. Lalagay nyo dun sa remarks, slight polychromasia observed. If more than 11% of all red cell population on your blood smear is polychromatic, you then report it as 4+. It's good that we know these abnormalities, but in the lab, it would be a lot better if you know how to report them properly. Are we clear with that?
Yes.
Yes po.
Okay? O, ito na rin yung binanggit ko kanina, yung hemoglobin content. Again, what's that condition resulting to hyperchromic RBC? What's that condition?
Hereditary spherocytosis.
You have there spherocytosis. Okay? So when it comes to your poikilocytes or red cells variation in shape, it could be because of any of the following reasons. Number one, it could be because of abnormal maturation of cells or abnormal development. It could be because of cell membrane abnormalities. Let's say, sir, I have a problem with proteins. I have a problem with lipids. Automatic. It will affect the shape of your RBC. Or let's say, sir, my red cells were destroyed. My red cells were exposed to trauma. So you can expect there changes in the shape of your RBCs. Or let's say, there would be abnormal hemoglobins present inside your RBC. That could also probably a reason on why your red cells vary in shape. Okay? So first one here is that there could be poikilocytes, isa lang naman to, because of developmental problem. A while ago, when it comes to the size, di ba meron tayong macrocytic RBC? When do you form macrocytes again?
Of maturation,
If there's abnormal maturation. Tama? So if red cells are macrocytic because of abnormal maturation, expect that your red cells will also be elongated. Okay? Elongated because it is a signal that there has been nutrient deficiency on why your red cells did not mature properly. Imagine, yung MCV nyo can go as high as 125 femtoliters or even higher. This nuclear maturation defect in your red cells leads to the development of macrocytic cells. And if you will check the shape, they're no longer discoid or round in shape, but they may be a bit elongated. Kaya sometimes you call them as ovalocytes, oval-shaped cell. And as to some studies, it has been revealed that having oval macrocyte or ovalocyte may also be associated with deficiencies in the cholesterol content of your cell membrane. Diba yung cell membrane natin merong cholesterol, diba? Equal amounts of cholesterol and phospholipids. So as to studies, having an ovalocyte here may also be due to deficiencies or reductions in your membrane cholesterol. So if it's wide and it's elongated, you then call it as ovalocyte or oval macrocyte. And again, it is formed whenever you have defects in the maturation or any deficiencies in the nutrients needed by your maturing RBCs. Next to that would be poikilocytes because of cell membrane anomalies or cell membrane abnormalities. Okay? Ano uling tatlong component ng cell membrane natin?
Lipids, proteins,
You have carbs, proteins, and lipids. Tama? So with these membrane abnormalities that we're going to deal with, it could then be due to any deficiencies or any excess in those components. For example, first up here is your acanthocytes. Yan, ito yung acanthocyte, this one. You have their spikes on the membrane of your RBC. 3 to 12 irregular spikes at times. That's why sometimes acanthocytes are called as spur cell because of those spikes, or sometimes they are known as thorn cell. Okay? And you form these spikes because there are abnormal ratios of your lipids. There is an abnormal ratio of lecithin and sphingomyelin. Kaya ka nagkakaroon ng spikes. And as you form these spikes, you lose your, you look at the picture, you lose your pallor area. And again, what will happen to your red cells if you lose their pallor area?
easily lyse.
Then become susceptible to lysis. Tama? Kaya, at times, these acanthocytes are associated with liver diseases. It's associated with hemolysis, hemolytic anemia, because of that lack of pallor area. It could be with hepatitis or any problems affecting your liver. But one of the most prominent condition resulting to an acanthocyte would be a disease called beta lipoproteinemia. I don't know if you can still remember, but beta lipoprotein is otherwise known as LDL. Does it ring a bell? Familiar kung sino si LDL?
Yes po.
Diba? Tinatawag nyo as bad cholesterol, right? Bakit? Because it transport cholesterol from your liver going to your tissues, right? Which is actually technically not bad. Okay? Kasi your tissues, your cells need cholesterol. Tama? The only time it becomes bad, definitely if it's too much, right? But you look at this disease, beta lipoproteinemia, meaning you don't have LDL. You have deficiencies in LDL. So if you don't have enough LDL, you will not transport enough cholesterol onto your cells and onto your tissues. That's why your lecithin and sphingomyelin becomes aggregated. Your lecithin and sphingomyelin becomes improperly distributed. Lecithin and sphingomyelin are phospholipids. So nagiging nag-iiba ngayon. Okay? That's why you then form the spikes that you see now on your RBCs. Is that clear?
Yes.
Yes po.
Yes po, sir.
Okay, for a while lang ha. Time out lang. Okay, sige, then going back. So next poikilocyte here would be echinocytes. Echinocytes, as you look at this picture here, it also has spikes. Yun nga lang, the spikes are way shorter as compared to your acanthocyte. And with echinocytes, the spikes are all over your cell. Okay? That's why sometimes your echinocytes here are called as sea urchin cell, sometimes yun yung tawag sa kanya. Sea urchin cell or even crenated RBC. And usually, physiologically, you form crenated RBC, number one, if there is a depletion on your red cells ATP. You don't have enough ATP, which causes changes in the osmotic pressure of your RBC, resulting to echinocytic appearance. Second could be, you can form echinocytes whenever you expose your red cells in a hypertonic solution. It will then crenate and later on it will then be destroyed. And sometimes, it could be formed because of improper blood smear preparation. Yan, especially if you are air drying your smear in front of an electric fan, in front of the aircon. So sometimes you can have those artifacts that may then affect the integrity and structure of your RBCs. But physiologically, it is due to changes in the osmotic pressure within your RBC from a depletion of ATP. And sometimes, if you form crenated RBCs because of kidney diseases, because of renal diseases, you further call it as Burr cell. Okay? Pareho lang sila ng itsura, ha? But if it's associated with kidney diseases, any renal diseases, again, it's because kidneys give you erythropoietin, right? You may then have crenation of RBC resulting to the formation of echinocytes. And you appropriately term it as Burr cell. Do you follow so far?
Yes po.
Yes,
Yes
po.
po.
Then if you will look at the next one here, di ba? If you will describe it, yung mga nasa arrow. If you'll describe it, there is hemoglobin at the side of your cell, at the periphery of your cell. It will be followed by a clear area, and then at the center, magkakaroon uli ng hemoglobin. Okay? That's why podocytes here sometimes are being termed as target cell, or you just use your imagination. On top view, it looks like a Mexican hat. Top view, isipin niyo yung Mexican hat. Mexican hat cell or target cell. Okay? So in this case, you form this podocytes here because there is an increase in concentration of your lipids. You have excessive phospholipid, you have excessive cholesterol, which then results to improper distribution of hemoglobin. Nagkakaroon ng imbalances in the distribution of your hemoglobin. That's why it resulted to this one. And you can encounter presence of these podocytes in cases of, again, liver diseases. Sometimes it could be present in iron deficiency anemia, in the removal of spleen, but most prominently of all those conditions, it is commonly seen in cases of thalassemia. But just to make it clear, if you have thalassemia, there would be different poikilocytes present. It's not only limited to podocytes. Okay? It's just that in cases of thalassemia, most of the time, ang nakikita na madalas would be podocytes. But it's not limited to podocytes. There could be other poikilocytes that could be present in cases of thalassemia. Okay? Then with the next one here, what do you think will happen if red cells are spherocytic? What could be the effect of having these spherocytes on your blood?
No color area.
No color area.
O kung wala ngang pallor area, what will then happen?
Lysis.
Susceptible to
Red cells will then be susceptible to lysis. Tama? You call it spherocyte because the term sphero means ball. Okay? Kasi mukha siyang bola. Diba? Yung mga walang pallor area na yan. And having these spherocytes here have been associated with any of the following. Number one, whenever red cells are exposed to extreme temperature, you may lose that pallor area. Parang you are melting your red cells, resulting to spherocytes. It could also be due to antibodies. Antibodies cleaving your RBC, resulting to a spherocyte. But membrane abnormality-wise, it could be because of deficiencies in proteins on your red cell membrane, particularly with this. Yan, most prominent. What's present inside your RBC? Is it potassium or is it sodium?
Potassium.
Potassium. Tama? Sodium should be outside. But because of osmotic changes, your red cell membrane here becomes easily permeable to sodium. Pasok lang ng pasok si sodium. And because of that, it creates changes on your cell structure, resulting to this mouth-like appearance. Okay? So you can encounter presence of these stomatocytes pag meron kang liver disease, cirrhosis, alcoholism, or yan, yung pinaka-popular sa kanya is if your patient has RH null condition. Are you familiar with RH blood group system? Narinig na ba yan, yung RH blood group?
Na-mention ko
You know
lang.
it for sure.
Yes.
Diba? Yan yung positive tsaka yung negative sign. Right? So, if you say RH null, or for example, your blood type A, and it's A negative, it means to say that you don't express the antigens of your RH blood group. Okay? So, if you don't express those antigens in your cell membrane, it will then be classified as RH null. And having RH null then results to cationic imbalances, kaya pasok ng pasok si sodium, thus resulting to the formation of stomatocytes. Okay? And then last one, for membrane abnormalities would be your elliptocytes. It is also elongated but it's narrow. If it's elongated and broad, anong poikilocyte yun? Ovalocyte. Tama? But this time, if it's narrow and elongated, parang rod or cigar shape, you call it as elliptocyte. And it has been associated with cytoskeletal protein deficiency, particularly protein band 4.1. You don't have enough membrane protein band 4.1, resulting to the elongation of your cell membrane, which is sometimes seen in cases of iron deficiency anemia or even in thalassemia, you can encounter such feature. Okay? So again, the first two set of poikilocytes that we had, poikilocyte because of developmental problem and poikilocyte because of membrane abnormalities. The third one would be you can have poikilocytes because of injury or because of trauma. And the first one that we have here is called as schistocyte. Schistocyte, or sometimes it is known as schizocyte. And when you say schisto or schizo, it means that your red cells are or have been splitted into two. Okay? Schizo or schisto is split. It means split. You separated them. Okay? So question is, sir, when will it happen? Okay? When will I split those RBCs? Usually, it could be because of a problem within your blood vessels. Imagine, this is your blood vessel. Let's say, on your blood vessel, there is an injury. Let's say, on your blood vessel, there's a clot. Ito yung clot. Or let's say, on your blood vessel, there is prosthesis. Alam niyo yung prosthetic heart valves? Yung mga nag-undergo ng bypass, yung may mga nilalagay na stent sa mga ugat nila. Familiar kayo doon? Pag nababypass, yung isang
Yes
pasyente.
po.
Yes.
O just imagine, this is your vessel, pwedeng merong prosthesis, pwedeng merong clot, pwedeng merong injury. Imagine, here comes now your RBCs. If red cells uncharacteristically bumps into this clot, bumps into this injury, and bumps into this prosthesis, red cells will be destroyed. Just imagine, pag tumama sila dyan, they will be damaged. Right? Remember, our blood vessels are sensitive. As much as possible, your blood vessels do not want anything to bind on its wall. But sometimes, because of injury, because of clots, merong didikit sa blood vessel natin. And once red cells bump into those area, red cells are destroyed. And once the red cells are destroyed, that's the time you form schistocytes. Kaya in such cases, you can encounter schistocytes in cases of DIC. Kung narinig nyo na yan, that is disseminated intravascular coagulation or coagulopathy, wherein your body keeps on producing unwanted clots. Sometimes you can encounter schistocytes in cases of burns. Kasi umaabot, especially mga second or third degree burns, where the vessels are already affected. Or in general, if it's dealing with your blood vessels, you associate schistocytes in cases of microangiopathic hemolytic anemia. Microangiopathic hemolytic anemia. When you say angio, you are referring to blood vessels. So meaning, when you say microangiopathic hemolytic anemia, red cells were lysed because of a problem in your blood vessel. And in cases of microangiopathic hemolytic anemia, it's like there's a clothesline effect. Parang nakasampay yung mga RBC mo. Okay? Doon sa blood vessel nyo. And once these red cells are totally splitted, that's the time you form schistocytes. Okay? Parang yun ay nasira na RBC natin because of those fragmentation within your blood vessels. Is that clear?
Yes, sir.
And then, last one here for trauma is the cryocyte. It's the crying cell. The cryocyte, or also known as teardrop cell. Dacrocyte or teardrop cell. Kasi it looks like a teardrop. Okay? So when do I form this, sir? O imagine, this is your spleen. Okay? And imagine, let's say, this is an abnormal RBC. Let's say, this is a macrocyte. Okay? Macrocyte yan. Remember, any abnormal cells in the body should be removed as fast as you can. So imagine, this is a macrocyte, so meaning it needs to be removed by your spleen. So this macrocyte here, or this abnormal cell here, will then go to your spleen. And if they are lucky enough to leave your spleen, they can then surpass your spleen. But once they leave the spleen, they were already squeezed and they were already fragmented. And the squeezing and fragmentation of the spleen from this abnormal cell will form a teardrop-like appearance. So to make it simple, you form macrocyte after your cell, your red cell, has been squeezed and fragmented by your spleen. So just imagine, what if, sir, my spleen is abnormally enlarged? So the larger your spleen is, the more chances of forming dacrocyte. Even in thalassemia, pwede kang makakita ng dacrocyte. Or in cases of myeloid dysplasia. In this condition, your marrow produces cells, but the ones they are producing are abnormal ones. So these abnormal cells will pass on to your spleen, but once they leave the spleen, if they are lucky enough to leave the spleen, you then form teardrop-like appearance. Are we clear with that?
Yes po.
Yes po.
Okay, then lastly, for your poikilocytes would be abnormalities because of hemoglobin content. And isa lang naman to. You call it as drepanocyte, or sometimes it is more popularly known as sickle cells. Sickle cells, or it could also be termed as menisocyte. Menisocyte. Yan, as you see on this picture, yan yung mga crescent-shaped RBC natin. And you form this crescent-shaped appearance of your RBC because of the polymerization of abnormal hemoglobin inside. And the sickle cells here are usually associated with abnormal hemoglobin, particularly hemoglobin S. That is the abnormal hemoglobin that we are referring to, which then causes changes on the shape of your RBCs. Okay? So again, when you say poikilocytes, these are cells, these are red cells, which vary in shape, which could be because of developmental problems, membrane abnormalities, injuries to your RBCs, or abnormal content of your RBCs. Then lastly, there are other poikilocytes that you may encounter in your blood smear examination, such as blister cell or helmet cell. Ayan, tignan nyo, mukha siyang helmet cell. Mukha siyang helmet, rather. It's actually the precursor of schistocyte. Bago siya maging schistocyte, siya muna siya. Blister cell muna siya. Before your red cells are totally separated, before they totally separate, before they are totally splitted into two, you will form an appearance like this. Pag naghiwalay na yan, yun na ngayon si schistocyte. Okay? Then, the other one here is bite cell or degmacyte. And usually, you form this bite cell because your spleen has removed Heinz bodies. Kailan ulit tayo nakakapag-form ng Heinz bodies? If your hemoglobin is denatured, right? And when is hemoglobin denatured again? When is hemoglobin denatured?
Walang G6PD.
If your red cells are exposed to oxidative stress, right? If you don't have enough G6PD, tama? Your hemoglobin will be denatured. So there will be Heinz bodies. So if there would be Heinz bodies, your spleen will remove those Heinz bodies but will leave a permanent mark or a permanent scar on your RBC. Isipin nyo, parang kinagat ng spleen nyo yung RBC. You call it bite cell kasi it looks like a beaten piece of cookie, beaten piece of donut, right? Because your spleen has removed those Heinz bodies that you formed. Okay? So again, when it comes to red cells morphologic abnormalities, it's either you have problems with the size, with the shape, or with the color of your RBCs. Stop muna natin dito kasi sa ibang section na nandito lang kami na nakapunta. But just to be fair with them also, okay? But with the next one, we will continue with red cell inclusions. Abnormalities pa rin yun ng RBC natin. It's when your red cells have abnormal substances inside. Diba, ang normal lang, if you will check them under the microscope, is that you have the pallor area, the rest is red. Right? But sometimes, there could be unwanted fragments inside. And you call them as inclusion bodies. So, we'll just continue with inclusion bodies of red cells next week. And we will further continue it with WBC abnormalities. Tutuloy natin. So ngayon RBC, the next week WBC naman. Okay? And then with regards to your quiz, you'll have your hemoglobin quiz this coming Monday plus your quiz about the things that we have discussed today. Hanggang po kilocyte lang. Okay? So, Monday yun ha, pareho. Do you have any questions or clarifications?
Sir, sa macrocyte po,
Yes.
yung normal RBC po possible din po siya maging teardrop.
Sorry, hindi ko maintindihan yung tanong. Sorry.
Yung normal RBC po, possible din po ba siya na ma-squeeze tapos ma-fragment
Yes,
po
yes. Even normal RBCs. Normal RBCs can be squeezed by your spleen. But if normal RBCs are intact enough, ibig sabihin, young RBC pa siya, enough pa yung proteins and lipids on its membrane. It can be squeezed by your spleen, but they can live normally. They can then surpass your spleen still looking normal. Normal na process yon na even normal RBCs are squeezed by the spleen, it's normal. But again, if red cells are still intact or bata pa yung RBC natin, there will be no harm or no damage. Most likely, dacrocytes will only be formed if the ones squeezed by your RBCs are the abnormal forms.
Salamat po, sir.
Sige, anything else? Wala na? Sige, kung wala nang tanong, sige, I'll see you later. Start na lang tayo exactly at 5 p.m. later sa lab. Okay? May nagtatanong, anong exact title sa RODAX? Actually, wala. Kasi it's a compilation of different disorders. You can find it in RODAX, by the way, or in any hemo books, pero kalat-kalat nga lang siya. You can find it in RBC disorders sa RODAX. Yung iba't ibang poikilocytes, yung iba't ibang variations that we have mentioned. But specific kung anong chapter, actually wala. It's more of compilations of those different morphologic abnormalities. So as we share it to students, it becomes easier. Para pagdating natin ng finals, you know already what microcytic, macrocytic means, what normocytic means, and etc. etc. Yun. So later, we'll just meet exactly at 5 p.m. for your laboratory class. Okay? So you may have your break. Thank you.
Thank you po.
Thank you po, sir.
Yes, sir.
Yes, sir.